This topic in EMEE6002 is about solar thermal system. So solar energy is light energy plus heat energy. So we can convert these energies into heat energy, or nowadays very often turn into electricity. But in these sections, let's focus on how to turn this solar energy in heat energy. This energy is widely used for domestic water heating. There are two types of solar thermal system, the passive and active type. So passive type means that it's only rely on the thermodynamics to circulate the water through the system. And there's no pump, no water pump is required. The flow of hot water in this tank depends on the convection's heat flow. And on the other hand, there is another system called the active solar system that we need to install a water pump to circulate the water in this solar thermal system. And also we can classify the system into direct and indirect system. Like what you have learned in nuclear power. The boiling water reactor and also the pressurized water reactor, the differences is the first one is direct and another one is indirect. So we can have a system like this, which is an indirect solar thermal system. There are two circulation loops. One loop is between the solar panel through a pipe system and then to this heat exchange. After the heat exchange, the cooled water will then pump back to the solar panel and be heated by the solar energy again. And then the hot water will feed into this heat exchange water tank. And then water will be heated up in this water tank and clean hot water can be supplied. This is the diagram of a direct solar thermal system. So cool water will feed in to the solar panel directly and be heated by the solar energy. So the hot water will then be first stored in this water tank and draw to the domestic heating system when necessary. But the disadvantages of this system is that because water will pass through those solar thermal panel in the rooftop, where the hygiene level and where there may be infections, especially during these days, we are very worried about the virus spread. So this is not safe because the bird flu or any dirty rainfall can then contaminate this water tank, and the water cannot be used for drinking water. It can be just used for washing hands or taking a bath. And there are different types of solar thermal collector, including the flat plate. So this can maximize the surface areas that can be in contact with the solar energy. Another one is the evacuum tube. When water passes through this evacuum tube, so it will absorb the solar energies shine on this tube, and then the energy level will increase. It has the high efficiencies, talk about 50%, compared with the efficiency of the flat pan is about 40%. Let's do some calculations. Now assume the overall system efficiency is 40% and the annual solar energies is about 5,500 megajoule per meter square. So in a meter square of area, about 5,500 megajoule will be received annually. So this can be calculated by measuring the energy loss due to mismatch and also the effective aperture area of the collector. Let's say we have 8 meters square of effective area of this collector. Then the energy used will be quite simple. Multiply by the annual energy that received by 1 meter and multiply by 8 meters because we have 8 meters of energy panel, and then multiply by the efficiency of 30% and multiply by the 80%, which is 1 minus 20%. The 20% is the loss due to mismatch. Then we can find out the energy per year is about 14,000 megajoule per year. So this is the way how we make use of solar energies to turn in heat energy. So during this conversion process, the solar energy is directly turned into heat energy without passing through other form of energy like electricity. In the next sections, we'll talk about how to harvest solar energies in form of the electricity energy. See you.